Okay.
So, sorry, this is only slightly less illustrative than I wanted it to be. So, this is what we quickie demo here of what we currently have for GL CompBench, which is a sort of a compositing benchmark utility that we've written, and it's running through a software ES pipe, so it's certainly nothing exciting. But the idea here is we have a sort of effectively plug-in kind of a test framework for doing compositing operations, and the overall idea is to kind of be able to split out the window system interaction from the actual from like texture uploads to the actual rendering operations, so you can have data on what each of those pieces takes within a given frame of compositing. Okay, and so I only mentioned the software pipeline because you can see the frames per second of one on that last test, which doesn't look terribly awesome, but that's sort of the point, is just to give us some different test cases to play around with and to get some data out of there. So you can see we're currently measuring, in addition to the overall frames, the event handling time, the actual drawing time, time to get the new data from the screen and to update the actual GL texture. Now, this is an extreme fallback case. So we're for example, not using EGL image pixmap to handle this particular case because, again, it is a software pipe. You're limited on what you get. If, for example, Alexandros could actually hook up the VGA connector to his netbook, then
You can build the GLX flavor.
sure. But I mean, anyway, the point is that we've attempted to provide appropriate support for all the cases that we've run into so far, in terms of just the general framework. Okay, it's very easy to add new tests, and part of what our goal is here. Here, I'll go back to the notes now, just to kind of, since everybody's sort of seen what we've done thus far. Come on, go away, Unity. All right. Okay. So again, basically just to get the ball rolling for proof of concept, we have some very simple tests that are in there now, not doing anything terribly interesting, other than some basic, translucency blending. But again, the goal is to twofold really. One is to grow the actual number of test cases we have available, and also to see if there's additional data that we ought to be collecting in order to make the results more meaningful. So, as a first cut, one of the things that we'd like to do is based on some of the other work that we've done for both porting existing compositing window managers to support OpenGLES, as well as engaging some new ones, is to basically model the effects that those compositors implement in our test framework. And that's again, the reasons even there are twofold. One is, again, we get more tests and everybody's happier that way, and we get to run these things across more platforms. But also it gives you a way to not only track the behavior of a given plugin or a compositor from release to release, but it also provides you with a nice test bed for being able to evaluate new compositing effects, new rendering effects. So if you've got, for example, we were talking to the guy who maintains a library called Nux, which is part of what the Unity plugin to Compiz uses to do some of its OpenGL rendering. And the idea of providing him with a test bed, he's concerned that effects that he tries out on a desktop GPU may not be suitable for an embedded GPU, and this gives us the ability to try things like that out before we worry about final versions for release and things like that. So as I say, by way of new tests, we're going to be looking at the pieces we have the most familiarity with, so that mostly means Compiz and some of its core plugins. We've done some work with KWin as well, so we'll definitely be looking for some test cases from there. And we'd like to would like to extract some cases from Surface Flinger as well, though admittedly I don't think we've done quite as much real analysis there to see what makes sense. So what do you guys think? What, based on the limited amount that you've seen, I mean, I assume that as new as the component itself is, not very many people have had a chance to play with it. But I guess maybe we can start on the actual data generation side. So is there anything else that you guys think that we should be capturing? Better Windows system data, less Windows system data?
We have a system that's really versatile, so it's very easy to add, points we can measure.
And I mean, basically the tests themselves are, it's a very simple interface. The test is given a chance to do sort of offline initialization. In other words, stuff that you wouldn't normally get penalized for in a performance case. So all of your shader initialization, that kind of stuff, can all be done before the test really starts. And then it's given, a chance to do kind of a pre-run, whatever initial state setup you need to do that's based on a fresh switch to your context, and then it's just told to draw whenever we get an event from the Windows system. And we also have the ability, by the way, to not be event driven effectively. So we can basically say each time through the event loop, even if you didn't get an event, go ahead and redraw. So there are different ways that we have also of kind of measuring different characteristics there. So we can be a little bit not Windows system agnostic, but we can be a little bit less, bound to the behavior of the Windows system that way.
One aspect of that is that we need to, so for Abric, for example, we need to find a specific way to run GL conference, right? So, and we have to decide what's the best way to run it to get meaningful results. So, do we need to run with this switch on or off, or this is?
So, do you think we need a minus Abric switch, or are you saying just a standard list of options that are suitable for Abric runs?
Yeah, the second one. So
okay.
we need to decide what's the best way to run GL conference to get results from the test in an automated fashion. Or even we can have multiple tests, so we need see different things. And we need to identify those.
Okay.
Use cases.
So, right. I guess another thing worth mentioning here is that the default as it stands right now is to run each test across 5 iterations, where an iteration by default is 3 seconds. So you get every 3 seconds you get a frames per second measurement, and that happens 5 times, and then you move on to the next test, which does the same thing until it runs out of test, and that's it. There are switches for all of that, so you can change the default iteration length, you can change the default number of iterations, and you can run continuously. So at the end of the list of tests, you can make it recycle back to the original, to the first test in the list and go again. Which is, again, if you happen to catch the demo the other night, I think is sort of the mode that we were running in for that.
Yeah, the full mode is run forever.
Yeah.
Run only the first test, what's the default, translucence test, forever.
Right.
One question I have, where would I find a complete list of all the tests? I mean, it's pretty much summarized.
Actually, we don't spit that out at the moment, but you think that would be useful?
I think that would be useful to at least see what is being tested at the moment, because then people can think of improvements on top of that.
Yeah, so
like I was thinking, for instance, my previous background was in Migo, so Migo Touch Compositors has a lot of tests that are in Vitorius in Python format, and they explain very well what they do in each of them.
okay.
So as somebody working for Migo as well, we get bug reports in the graphics server stating this test is failing on this specific test in the case.
Yeah, so I have one note here that says command line user interface additions. For example, we can specify which test to use or what parameters to use for its test, and I think we would cover that. I mean, we could also have a list.
Well, I think it's a little bit, in a way, it's a little simpler than that. I mean, not to get implementation specific, but basically you want to say, you know, you'll run a test, the stupid brick test that I wrote, right? You know, run, so the test is called brick, and here's what it does, and here's what it looks like. Just a loose description, so that people can, you know, if they want, they can pick and choose an individual test. And as I think, you know, Luke mentioned, it's if you get particular weird behavior on a particular test, you can get, you know, you can single in on that.
Well, I think it would be useful to be able to add a list of tests, because if you want to automate that, put it in Fabric and you run, you know, test X, Y, and Z on it in Fabric.
Oh, I see. You're saying and yeah. So I think, okay, so that's part of this. Okay, but we'll just go ahead.
Also, in case that you want to supply some specific test data, let's say for a particular test, that would be just a thing to have.
Yeah, it's more generic. Instead of being able to specify only one test, you can specify a list of tests
Right.
in any order that you want. So it's very easy to, yeah. Okay. So another question is, do we need to add parameters to our tests? I mean, the API to be able to add some parameters to tests. So
How do you mean?
as for example, I don't know, in the current test, we place the windows around a circle, for example. We could have a parameter that, you know, says, don't use the circle, use the square. I mean, it's very stupid.
Yeah, no, I understand what you're saying. So right now, we just totally allow the test itself to define that kind of behavior. Sure, we could do that.
Yeah, it's easy. I mean, but do we need it? I don't know. Right now, I don't think so, but perhaps with more.
Well, okay, so that in particular, I think makes sense to leave as test defined. So, for example, if you're going to implement the Cube plugin from Compiz, I think that brings with it an inherent sense of how the windows get laid out, right?
No, I mean, not necessarily. If you have like the 3D effect, then you need to know about like the window stack and layout and everything, but for just spinning a cube, it's really just...
Well, I mean, the main idea is here is you have two tests that are very, very similar.
Mm-hmm.
You won't need to write them two times. You have
Sure.
one time, so you can pass some parameter and do that all the way from the command line to the test run.
Okay, yeah.
Just throw a couple nulls at the end of your plugin vtable, then you can add options later if you need them.
Oh yeah.
Is there a way to do a profile dump in advance before you get into the test? The reason I ask this is composition operation is very memory intensive. And some of these graphic devices has accelerators, some don't. Some have incomplete graphic accelerators.
Mm-hmm.
I mean, in the traditional window at x86 side, we have 256 restaurant, for example, that's implemented in hardware. And we know that we can do XOR, we can do a whole bunch of things by hardware blocks. In some of the SoC for ARM, they don't implement every single restaurant for die area for all kind of considerations,
Right.
which tends to bias the result. And so if you can get a dump of the profile exactly, switch effect and all different, which unit you're using, which unit you're using, software to the emulation will definitely be helpful.
So what you're saying is, we also need information on what hardware it's running on.
Yeah.
You mean printing out the GPU, for example? Like what the renderer is? Yes. So
In some of the operations, you may not want to call the GPU. The AP with a direct access to the memory managed unit actually can operate faster.
sure. So right now, all the support we have is through OpenGLES. So in that sense, unless the implementation itself is doing something internally to use another piece of IP, this is all GPU specific. In terms of that, we can emit additional information. Actually, it's not on by default, but there are switches to allow a bit more verbosity in what comes out of this. So, you know, we could certainly easily emit the renderer string, for example, and it'll tell you what GPU you're running on. But as this test, at least as the framework itself is implemented, everything will be run, all the rendering will be run on the GPU. We're not leveraging, you know, there's not like a neon routine for something, and we can switch between that and the GPU at the moment. I mean, we can certainly look into that as a future enhancement.
One thing as well, with Compositors actually, it almost has all the setup needed to run as a benchmark itself. It won't be able to give you any more data than the frames per second you're getting now. But if you just want to test to see how well an effect runs, there's a benchmark plugin that I believe actually already spits out output to standard out. And then you can also control it via dbus, so you can just, you know, send a dbus call, you know, spin the cube and see what your frames per second are as it's doing it. Depending on how much detail you want, it might make more sense to have GL Components just drive Comps via dbus.
Yeah, that would be more accurate, but
I mean,
I'm not sure that's the way we want to go, because, for example, we want to support textures for whatever reason Comps cannot run yet, or, I mean, as a whole.
Well, I don't know that a benchmark of a Comps effect makes much sense if it's on a system you can't run Comps on.
Yeah, I mean, yet, but I mean. Yeah, but it's useful. I mean, although I'm not sure we should go through GL Comps for that. Perhaps we could have separate tests for using Comps directly.
Yeah, it's doable.
And have some number of tests for pure Comps.
Yeah. That's probably worth doing even whatever else we do with the GL Comps actually.
All right. Yeah. So as I noted, we can take a look at maybe writing some Pixman wrappers for some of the compositing operations and see if we can.
Well, the idea is that we can use, for example, the render extension instead of.
Oh, you mean and let the X server do it?
Hmm?
And let the X server do it?
Yeah.
Have you ever tried using Xrender directly? No. Yeah, it's fun.
It's certainly worth the evaluation.
Right.
Just for the sake of the discussion that we just had, you know, to be able to say, is what we're doing, you know, are there platforms for which it makes sense to use?
That doesn't tell you what you want to know though, because Xrender, depending on what driver you're using, could be going through the GPU just as well as GLES's. Because the driver can hook that accelerator. So if you want to see...
Yeah, that's what I was thinking more of enforcing doing the actual, using the Pixman compositing routines directly.
Yeah.
From within a test routine.
So just using an image to compose.
Yeah, and seeing if that's, and so basically, I think what we're saying is, you have the ability to do the routine through GLES, and you have the ability to do the routine through Pixman, let's say, I mean, forget about how we actually do it internally, and an option to switch between the two, and you say, well, if I'm doing these kinds of operations that are described by test X, on this platform it's actually faster to go through, you know, the Neon routines than the GLES routines, for whatever reason. I mean,
Yeah, sure. Faster is one aspect, but
Yeah.
performance
power,
is another aspect.
absolutely.
And offloading the CPU is
Right.
another aspect.
And as we discussed in the other session, that's the power measurement part is going to be a large part of the challenge, because the physical instrumentation to do it isn't always immediately available to us. But I think it's still worth looking at doing.
Yeah, it's still work, but in the end, should we care about those platforms? I mean, the GPU is the future. So if one platform is better at doing compositing in software with Neon, then do we care about that?
Yes.
Okay.
No. So here's why. Okay. We represent a balance between, you know, between the sort of general interests of the community as well as the members that make up Linaro. And one of our jobs here is to, I mean, I think this came up in the GLMark discussion as well. One of our jobs here is to provide recommendations based on what we see across different platforms. And so if we're saying, on this platform, this is faster, this consumes more power, then the vendors are empowered to make better optimizations within their implementations in order to achieve whatever their goals are as well.
Okay.
So, you know, we're not necessarily making, you know, I mean, we can, in other words, we can say across the board, we think you should be using the GPU to do all this kind of stuff because we think it's generally more flexible, for example. You may not, with Neon, you may be able to do the basic composition part, but if you have effects, for example, that may not be an option.
So you're talking about having a specific test that, for example, the simple translucency?
Sure.
Just for Pixman or whatever?
Yep.
Yeah, because I don't think we can have a generic interface to be able to choose for all tests, do GL.
Yeah, sorry. Perhaps I misspoke. I wasn't suggesting that would be possible. But I think where we can do that, it does make sense. No. I mean, obviously, if you've got a very elaborate shader for producing all kinds of interesting effects, you know, let's say you want to have a ray traced scene of your desktop, that's probably not the right thing to do in Neon. But I still think it'd be worth having the ability to evaluate certain basic compositing operations there.
Yeah, that's true. For single tests, that's fine.
Along with the whole idea of this being useful to track driver regressions, having the Pixman test will also give us like a baseline.
Mm-hmm.
And so if you know, the GPU is going slower than Pixman for this particular kind of test, then
And it didn't used to. Yeah. No, that's an excellent point. So yeah, I think for at least some of the basic tests, that's good. We can definitely look into that.
Is there any test that can do multiple layers of translucency calculation?
well, the stock test does, doesn't it? All of those windows it's compositing there, transparent on one on top of the other.
Multiple layers.
Yeah. Yeah.
Multiple windows have like a common area that overlap.
Yeah, I mean, the test is sort of, it's a very basic test, but it's intentionally instrumented so that there is overlap between the windows. So basically, what the input to any given test is, it gets a rendering context and whatever state that it needs to manipulate ES, and a list of windows. So it can do, the test itself can do whatever it wants based on that. So the default test simply takes whatever list of windows it was given and, you know,
Composite one.
yeah, you know, with a basic kind of revolution around the screen. That's it. That was, you know, for us, that was good enough to have something that we could develop the basic framework around. And then, you know, we've started adding new tests as we've gone along. And so that a lot of the goal now for this cycle is to come up with these new ideas. So we definitely, I'm being a little bit terse here because we had another session on future work for Compiz that we're going to be doing in the current cycle where we did also talk a little bit about which plugins might be more interesting, at least to start with initially.
Well, the reason I ask this is because in prior experience, I've seen that most of the blending and translucency and alpha blends is based on fuse multiply add operations.
Mm-hmm.
Some hardware devices can do cascaded fuse multiply add, but they only can do certain number of stages.
Right.
So there's two ways. One is that you do a priori Z-sort. The other one is you do post composite. Now, the one that do a priori typically has ability that to pre-sort and then pre-calc, so the operation is cascaded. The one that do post will typically require multiple memory buffers. So I've seen situation that when you try to do 5, 6, or 7 more layers and then just blow up on the memory.
Right.
So if we can on a benchmark program to export which point it fails, it will be very interesting and useful information.
Sure. And some of that is, I guess, is dependent on like the format, right? The pixel format, for example. But yeah, so I think hopefully we've captured enough of an action to be able to investigate that appropriately. Obviously, there are other things that you might be doing. So as I mentioned, if your goal is to yield a novel lighting effect, or you want to make it look like all of your windows are on fire or something like that, there's a limit to how you can actually achieve that. So the shader for the basic test is very simple. It's pretty much does what you suggested. But some of the other shaders that we're looking into have a lot more, a lot of additional calculations in them that would make it tough to do with something like neon, for example. Okay, so let's see, what else do we have? Oh, right. So right now, everything is pretty much monolithic. In terms of implementation detail, the tests themselves are basically this is all done in C++. There's a base test class, and then the tests derive from that based on whatever else it is that they need to do. But there was talk that we had of basically making it quite modular in the sense of making the test loadable. So to people, I have limited experience with the performance impacts of doing like something like having something like a test framework where each test is a DSO that gets loaded and that kind of thing. Is there? Do you guys think that there's likely to be like a performance behavior hit based on doing that?
Not that much.
No.
Okay. I mean,
we can load everything on the start, and also there's two ways to load the symbols then to resolve them.
Mhm.
A lazy one, and,
Right.
there's another one, LD now or something like that, so
Okay.
you can resolve them at the beginning and don't have it.
And
Impact
they're
later.
still spending like three opcodes to just get to the actual symbol later on. That's it. Very simple.
okay, so there's literally a hit, but it's not measurable necessarily. Okay, because that seems like an option that might make it more encouraging to other people that want to come in and contribute tests and that kind of thing. If they basically just have to do their sort of a smaller piece rather than working with the entire framework every time. Not that it's so huge or anything like that, but if you're developing natively on ARM, for some people that's a perceived benefit.
The only thing we will miss is some of our framework helpers that we have. So perhaps we need to expose those to a library with chill content like that.
Sure. I mean, I think.
Huh?
Why would you need a library for the plugins to have that? Just make a header file, and when you open the plugin, it has access to all the symbols. And
Uh-huh.
I'm not sure if this is very safe to do.
somebody that's on this plugins where
Really? Okay. Well,
So I mean that's all fine as well. I guess I'm treating those discussions slightly orthogonally. In other words, is it the right thing to do? If it is, we can worry about how to implement it. But I mean, I think that's the thing. Right now, it's not exactly set up to be treated as a developer kit kind of thing. So, you know, we certainly would need to work out how to do that if we think that that's a good idea. So, okay. Other stuff?
More ideas? Okay.
My concern, I mean, the way that we've done this is more focused on effects, I suppose, more than anything else. Are there ways we could better sort of extrapolate the way that the actual sort of window management side of compositing window managers is done?
Trevor?
Some compositors are using 2D LED. So you presume the 2D LED to
How do you mean?
I mean, the benchmark to test the 2D LED for performance.
We covered that point earlier, so they talked about Pixman and Neon.
I mean, especially 2D LED, some using GPU.
You mean like OpenBG or?
Using the blenders on each GPU and all that stuff, the 2D stuff on.
Yeah, some they export some specific 2D LEDs. It's not standard interface.
I see. So are there platforms that you had in mind in particular that do that? That export those as utility libraries?
For example, Soviet Link can use Toby B to do some acceleration.
Okay.
Yeah, I think that we can.
Yeah, so that was. Well, if we just make the test plugins, it would be easier for someone that has access to those libraries to use them.
Right.
And we don't have to put them into code with, it's not something that's general in the library.
As far as like how compositors do things, the old ones basically do things the exact same way, because the K-Win compositing was basically a copy of the Compass compositing, and then the Compass GLES compositing is inspired by the way that the K-Win GLES compositing was done. So.
Yeah, I don't think there are many ways to do that anyway. I mean, perhaps
Yeah.
there are some slight differences, but in the end,
Yeah.
some.
I mean, there's obviously some differences because K-Win works down there. Compass doesn't. That's more a bug on my part than a difference in implementation. So.
How did you manage to put the circles there?
I didn't do that. I was looking at that, wondering how you were doing it with typing.
You click the list button, you highlight the list there and you click list and it indents it one more.
Yeah, no, it's just that's Alexandros's color code, but he's not doing it, so I was confused more about how that was actually happening live. But yeah, no, that's it. You can create a basic bulleted list, and then if you change the indentation, it changes the bulleting.
Oh, it doesn't seem to be updating on the screen, right?
So, and we can clean up the notes on that later. That's not a problem. Okay, so
more performance info to expose. I didn't hear anything on that from me. So I guess it's enough. unless we think of that.
Yeah, I mean, unless anybody's got anything else to add, like I said, the basics that we're doing are, through a given frame, it's basically interaction time with the window system, both on the event side and on the sort of window update side. There's texture upload time effectively, and there's just raw rendering time. Is there nothing else that you guys think we need to be measuring to accurately capture what's going on inside there? I mean, frames per second is just kind of the rough, container for all of those discrete measurements. And for some people, that's enough, and for some people, they want the lower level information. Obviously, if we were to do this in combination with additional profiling tools, so one of the other sessions that we had here is about getting the GPU drivers themselves to contribute perf events. And so if we combine something like this with something like perf, you get a better, I think, kind of, not quite call graph, but you get kind of a better relationship between what's going on at the application level with the workloads that it triggers on the GPU. So I think that's something that we should also look into as well. Actually, I'll just go ahead and add an action for that.
For example, we can add a source to whatever tool you decide to use for benchmarking stuff on Monday. Add a source for the GL content output, so you can feed that data from GL content back into the
I see.
tool. Or something like that. We need to think about it. Because I think we will have many sources of data, so we need a way to gather all of them, correlate them. Display them.
So I just want to, is there sort of an explicit work item that you think falls out of that, or?
Yeah, although I think it belongs to the other blueprint better.
Okay, well, I'll say that we'll add that, but what do you want to add to the other blueprint?
Okay. So we can say that we need to consider GL components as a source of profiling data, integrate that to our benchmarking and tracing.
I see. Do you think that requires some kind of a filter? I mean, something that, I mean, the output of GL Bench at the moment is fairly, it's not exactly freeform, but it would require some kind of text parsing to yield some kind of discrete, meaningful data that would go to the profiling display. Do you think that's part of the profiling display, or do you think that's something we need to implement in CompBench to make its output more suitable for consumption?
Well, if we come up with some standard format that we can use, then perhaps we can put it in CompBench. So we can say export it in that specific format and do that here. But if the format of that profiling tool is a bit more free, I don't have it.
I know we don't know the answers yet, but I guess I'll say that we may need to add an option.
Yeah,
it's just since we have some other options going in, I want to make sure to identify that. So.
In any case, we can add something like a wrapper around the GL Bench to do translation.
Okay, so I think that's everything that we wanted to cover based on our initial thoughts, and certainly if you've got any other ideas, we have a few more minutes on this session, and we can, we'll certainly accept them at any time later as well. This is really about just, as you know, getting everybody into a room together to kind of gel their thoughts. So in terms of visibility here, Jail Comp Bench is hosted on Launchpad. There's binaries available on the Graphics Working Group PPA, and there's also Tarball is also available if Debian packaging isn't for you. And please, go take a look at it, play with it, heckle us, give additional suggestions. It's all welcome. We're just really trying to fill a gap that we perceived here in some of the tools to evaluate the stuff that we were tasked by the members with doing. So, it's always a bit of a work in progress, but I think overall, I personally am pretty happy with the way that it's gone so far. And I think if we can get some new tests and get some of this integration with our overall profiling effort tied together, I think it'll get a lot better. You can probably expect, overall, the working group releases its components on a monthly basis. Some components may be more like every other month, but you can pretty much expect something like once a month. I think right now we have an 1104 release of Comp Bench, right?
Yeah.
As well as GLMAR 2.
Yeah, it depends if we get a chance to do some work in the meantime.
Yeah, it's all, so we have the sense of this, 6 monthly planning the way that Ubuntu does, but the releases themselves are not tied in the same way. So, probably on about monthly intervals throughout that cycle, we have release points. And if there's been work on that component, then you'll see a new version of it.
And we're also trying to push the package into Universe, so I think it will land better for Lyric. But still, it's going to be out of date, right? So I don't know. Jenny, do you know when the freeze is approximately? For Universe,
upload freezing.
Yeah, for Universe packages.
Final freeze, isn't it?
Is it final?
So not feature freeze, right?
No, I guess no.
I think just like now, like 3-4 weeks before release.
Okay, yeah, so it's,
But we still can get exception even after the last week. But it's better to get anything uploaded as fast as possible, even if it's not perfect, because then it's much easier to upload and have the new package processing. So.
And with a component like this, we generally know pretty well ahead of time what's going on. The only thing that I could imagine is if we do something that is affected by some driver update or something like that. But even that. Was there anything else?
not for me.
Okay. Anyone? All right. Thanks, everybody. Much appreciated.